The digital audio system provides the capability for communication between the aircraft and ground, between the cockpit and cabin, and among the cockpit crew. Two multifunction control display units on the pedestal are the primary means for selecting and tuning the radios. The radio page is the main interface, which allows selecting communication frequencies, navigation aids, and transponder settings. The control cursor device and the primary flight display are the secondary means for selecting and tuning the radios. 3 audio control panels, one for each crew member and one for the observer, provide the audio selection for all audio communications to and from the cockpit. They also provide aural warnings from the MAU and other systems such as TCAS. The desired channel is selected via different buttons on the ACP. The service intercom buttons enable the pilot to select any radio to speak. A light illuminates inside the button to indicate that it is pressed. Only one microphone selection button can be selected at a time. The audio selection buttons enable the pilot to select any radio, navigation aid, or interphone channel for listening. A light illuminates inside the button to indicate that it is pressed. Any number of selections can be made simultaneously. The telephony buttons on the right, emergency, ramp, cabin, are set up with a hot mic, which provides interphone communication on a telephony basis. A light illuminates inside the button to indicate that it is pressed. Flashing of the light indicates a waiting call from or to the respective station. More than one telephony button can be selected at a time, with a maximum of one microphone selection button active. The audio selection buttons enable the crew members to listen on the speaker, interphone, or headphone. A light illuminates inside the button to indicate that it is pressed. More than one selection is possible. The volume control knob allows adjustment of the most recently selected audio. The volume display shows a 4-character code and a number between 0 and 100, denoting the volume of the last active microphone audio channel or the newly selected audio channel for 15 seconds. An incoming cell cal is displayed when the cell cal, the microphone, and audio selection button lights flash. By pressing the cell cal button, all flashing lights are extinguished. In case of an ACP failure, a push-in, push-out volume knob allows unlatched bypassing of the audio panel and adjusting the volume. The auto mask mic is also a push-in, push-out switch. When pushed out, it activates the oxygen mask microphone manually when auto mode fails. For transmitting, there are boom sets, handheld microphones, and mask mics. For receiving, there are headphones and 2 loudspeakers. To activate transmission via the microphones, there are push-to-talk hot mic switches on each yoke, and one push-to-talk button on each side of the glare shield. 3 jack panels are located within the cockpit. The observer's jack panel has an integrated push-to-talk hot mic switch. The Flight Service Interphone System provides communication between flight deck crew and cabin crew, or among the cabin crew. There are 2 cabin interphone stations, one at the forward and one at the aft section of the aircraft. A cabin annunciation system provides visual indication for the flight attendant.
To establish communication, the pilot pushes the cabin button on the audio control panel. The display on the audio control panel shows cabin call, and the cabin push button light flashes. If another audio panel is talking on the cabin interphone, the display shows busy. The microphone signal is routed to the cabin interphone stations, a chime of the cabin sounds, and the cabin annunciator illuminates. Once the attendant picks up the call, the green push button light flashes faster. Pressing this button again, the light becomes steady and the communication with the flight attendant is enabled. During the communication, the display shows the character cabin plus a number between 0 and 100, denoting the volume. For an incoming call, the cabin push button light flashes and a chime sounds. To pick up the call, the pilot pushes the cabin push button. At this time, its light stays on, and a display shows the characters cabin plus a number between 0 and 100, denoting the volume. After the call is completed, the light extinguishes, and the display shows the last active radio.
To establish an emergency call, the pilot has to press the emergency button. Then it sounds a triple high-low chime through the PA system, and a red light illuminates at the ceiling of the flight attendant station. On the ACP emergency button, a green bar flashes until the flight attendant picks up the call. Once the flight attendant picks up the call, the green bar flashes faster. Pressing the button again, the light becomes steady and the communication with the flight attendant is enabled. For the cabin crew to make an emergency call, emergency button must be pressed in the cabin interphone station. In the cockpit, on the ACP emergency button, a triple high-low chime will sound, and the green light will flash until the pilot presses it and establishes communication.
The ramp interphone subsystem provides communication between crew and ramp personnel. There are 3 ramp interphone panels, one in the forward section of the aircraft, along with the external power AC receptacle, one in the mid-electronic bay, and one in the aft section of the aircraft, along with the external power DC receptacle. Each ramp interphone panel contains an interphone jack and a cockpit call push button to call the pilot. A ramp call horn is installed in the nosewheel gear bay to summon ramp personnel. It sounds when the push button on the cockpit left or right console is pushed. The passenger address PA system allows announcements to be made to passengers either by pilots on the flight deck or the cabin crew members at their stations. The announcements are heard through speakers located in the cabin and in the lavatories. The use of the PA system is prioritized. The announcements from the flight deck have first priority and override all others. The announcements from the cabin override the pre-recorded announcements which override the music system. Announcements in the cabin are performed by lifting the handset from the cradle and pressing and holding the PA button. To make a passenger address from the flight deck, first press either the PA button on the center pedestal or on the audio control panel. By pushing the PA button on the center pedestal, The pilot can speak through his boom set or mask mic without hands, and with hand mic by activating the hand mic push to talk. By pushing the PA microphone selection button on the audio control panel, the pilot can speak through any mic except the mask mic by activating push to talk. The mask mic is a hot mic. When the PA microphone selection button is selected, the light in the button illuminates. If push to talk is activated, the display shows PA, TX, and a number between 0 and 100 denoting the volume. If another audio panel is talking on the PA, the display shows busy. To terminate the call, the PA microphone selection button is pushed again, the light extinguishes, and the display defaults back to the last active radio. The DVD-R digital voice data recorder system is capable of receiving, recording, and preserving all required flight data parameters and voice recordings on board the aircraft. It combines the function of a flight data recorder with the function of a cockpit voice recorder in a single solid-state recording unit. The digital voice data recorder unit is capable of recording the most recent 120 minutes, 2 hours, of audio information, 25 hours of flight data information, 120 minutes, 2 hours of digital communication messages, and Greenwich Mean Time, GMT. The digital voice data recorder system has the following components: 2 identical digital voice data recorder units. DVD-R1 is installed in the forward E-bay. DVD-R2 is installed in the aft E-bay. 2 impact switches, 1 each mounted near its respective digital voice data recorder. 1 triaxial accelerometer installed on the wing stub. 1 DVD-R control panel located in the cockpit on the overhead panel. 1 cockpit area microphone mounted on the frame between both windshields. The digital voice data recorder control panel uses standard input-output interfaces for a cockpit voice recorder and a flight data recorder. The test button, DVD-R test, is used to initiate a cockpit voice recorder and flight data recorder test within both DVD-Rs simultaneously. You can switch the forward-aft switch position to check the test status for either DVD-R1, switch to forward, or DVD-R2, switch to aft. The CVR erase button initiates the cockpit voice recorder erase function. For this function, the aircraft has to be on the ground and the parking brake has to be set. A headphone jack is available for audio monitoring. The position of the forward-aft switch also determines the CVR audio monitor source, forward or aft DVD-R. The cockpit area microphone, CAM, picks up area audio and delivers it to the preamplifier of the DVD-R control panel. The digital voice data recorder systems begin recording automatically. The cockpit voice data recorder begins as soon as power is applied and stops when power is removed from the unit. The flight data record function starts when the engines are turned on, or when the aircraft is in the air. No weight on wheels. Weight on wheels is false. It stops when the aircraft is weight on wheels and both engines are turned off. The DVD-R unit is internally time synchronized for direct correlation of the recorded cockpit voice to flight data information. Additional Greenwich Mean Time information is provided for absolute time marks. In the event of a fault or failure of the DVD-R system, an advisory message on the ICAS comes on. Some DVD-R CAS messages will be inhibited during critical phases of flight. There is fault segregation between the CVR and FDR functions. Generally, a fault occurrence in the flight data function will not influence the normal operation of the cockpit voice function, and vice versa. The Embraer 170 can also be equipped with an optional quick access recorder, QAR, installed in the pressurized rear electronic compartment. The quick access recorder is capable of recording a large amount of onboard data, which can easily be retrieved by the removal of a PCM-CIA disk, which can store more than 70 hours of aircraft operation, allowing for a change of the disk on a weekly basis. The quick access recorder receives the main set of parameters, which are the same as for the DVD-R, from MAU number 3. Electrical power for the recorder is supplied by DC bus 2 through a dedicated 5-amp circuit breaker. The quick access recorder is energized as soon as the aircraft is powered on, and the unit will start and stop recording in accordance with a logic programmed by the operator. No provision is provided to indicate the operational status of the system to the crew. The static discharge system offloads static electricity from the airframe to the atmosphere while the aircraft is in flight and offloads static electricity to the ground when the aircraft lands. In flight, this prevents the dangerous effects of lightning discharges and decreases the interference on the radio communication and navigation. On ground, this system minimizes the risk of electrical shock to crew, passengers, servicing, and maintenance personnel. The system includes several static dischargers on the winglets and ailerons, rudder and elevator, and one discharger cable on the nose landing gear,
The inertial system computes airplane position, ground speed, heading, and attitude.
IRS operating modes. The micro IRU has the following operational modes: power up, alignment, stationary alignment, align in motion, auto realign, navigation, attitude, reversionary, align in motion, end of flight. Control of the modes is fully automatic, which means that no input is required from the flight crew to select or enter a mode. Power-up mode. The IRU will initiate the power-up mode when the IRU is energized or when the IRU is reset as a result of an IRS reset command being issued. During power-up mode, the IRU performs a built-in test. Alignment mode. The micro IRU automatically selects the correct alignment mode. The two possible modes are stationary align. The stationary alignment mode is the primary method of alignment. This mode is selected when the aircraft is on the ground and not moving. The time required to complete a stationary alignment varies with latitude, ranging from 5 to 17 minutes. The alignment may fail if the micro IRU senses excessive motion during the initialization sequence, or if the micro IRU fails to receive an initialization position. A position may be obtained from the FMS, GPS, or entered by the flight crew. Align in motion. The AIM mode initializes the IRS while in flight to recover full IRU navigation capability. This mode will be selected in the event of a power loss while in flight. The time required to complete an AIM varies as a function of airplane motion and ranges from 15 to 30 minutes. When the micro IRU is performing an AIM, the flight crew will be notified by an appropriate ICAS message. stationary alignment, and aim modes are performed in conjunction with the attitude mode prior to entry into the navigation mode. In order to perform an aim, the IRU requires GPS valid data. Should the aim fail, the micro IRU will remain in attitude mode, with attitude data available but with positional data unavailable. Auto Realign Mode. The Auto Realign mode is performed in conjunction with the navigation mode when the airplane is stationary to maintain optimal performance and automatically realigns the micro IRU between flights. Navigation mode. When the IRS enters into the navigation mode, it will remain in this mode until the system is turned off. Attitude mode. The primary function of the attitude mode is to rapidly establish pitch and roll attitudes after completion of the power-up mode. Attitude mode runs concurrently with the alignment modes, either stationary or alignment in motion. Reversionary attitude mode. This mode, also known as erect attitude mode, operates in conjunction with the stationary alignment mode. The IRS automatically enters the reversionary attitude mode after completion of the power-up mode. Align in motion attitude mode. This mode, also known as attitude mode, operates in conjunction with the align in motion mode. This mode provides attitude and heading performance. End of flight mode. This mode is performed in conjunction with the navigation mode. The micro IRU automatically enters this mode after landing when the airplane has been motionless for a period of 5 seconds. The end of flight mode stores navigation performance records, auto-calibration data, and other miscellaneous information after each flight. IRS operation. Initialization. The position initialization is automatically transmitted by the Global Positioning System, GPS. The position initialization may be manually entered via the MCDU, FMS. Push the NAV function key to display the navigation index page on the MCDU. Select the position initialization prompt from either the Identification or Position Sensors page. Position initialization page lists positions that can be line selected for initialization of the FMS using the load prompt. IRS abnormal operation. In the event of a normal aircraft power interrupt or power transient, no degradation in performance will occur due to the switching or operating from the backup power source. The two micro IRUs receive power from different primary and different secondary power sources. So, in the event of a loss of power to one micro IRU, the other micro IRU would not also experience a power loss at the same time. If both micro IRUs fail or suffer a loss of power simultaneously, an appropriate ICAS message will be issued and the flight crew will have to use the remaining navigation instruments and systems. Reversionary mode. The IRS switch on the reversionary panel changes the attitude and heading source from the onside IRS to the cross-side IRS. If the reversionary mode is selected, the FD modes disengage. The AP modes disengage. FD-AP can be re-engaged after the previous disengagement. The enunciation changes accordingly. IRS-1 or IRS-2. Comparison monitor. The comparison monitor detects a miscomparison between IRS-1 and 2, pitch, roll, and heading data. When data miscompare is beyond limits, the enunciation is displayed. The Global Positioning System, GPS, is a baseline system on board the airplane, and a second GPS is optional. The GPS module is a satellite navigation sensor, which uses the Standard Positioning Service, SPS, from Navstar GPS, Global Positioning System satellites. The baseline GPS module is contained within MAU-1 in the forward fuselage avionics bay. If the optional second GPS is installed, it is contained in MAU-3 in the center fuselage avionics bay. The GPS module receives satellite signals from an active antenna in order to compute airplane position, velocity, and time. The GPS interfaces are the clock, the optional ELT navigation unit, the IRS, the EGPWS, the FMS, the CMC, and the master warning function receives signals to display the GPS CAS messages. The GPS module has no direct interface with the flight crew. All device input data will come from other systems, and all output data will be routed to other systems. These other systems will be responsible for the display of output data and for providing input data. Any faults within the GPS will be reported on the Multifunction Control Display Unit, MCDU, and the message indicator on the PFD will illuminate. When the GPS has lost integrity, GPS RAIM above limits is displayed on the MCDU. When the integrity exceeds the limit, a RAIM will exceed limit is displayed, and when RAIM is not available, GPS RAIM unavailable is shown. Radio Navigation System. The Primus Epic radio system on board the airplane comprises the standard navigation functions including very high-frequency omnidirectional range, VOR, instrument landing system, ILS, distance measuring equipment, DME, transponder systems, XPDR, and automatic direction finder, ADF. The radio navigation system utilizes system modules housed in two remote-mounted modular radio cabinets. The DC Essential Bus 1 powers the MRC-1, while the DC Bus 2 via SPDA-2 powers the MRC-2. The MCDU is the primary means of selecting and tuning the navigation radios. A secondary means of radio control is accomplished using the CCD and the PFD. VHF Omnidirectional Radio and Instrument Landing, VHF NAV. The VHF navigation system enables VOR and ADF en route flight phase navigation, terminal area navigation, and aircraft approach landing phase navigation guidance, using localizer, glide slope, and marker beacon distance to runway threshold information. The receiver system automatically pairs localizer and glide slope channels to assigned frequencies. The VHF NAV system consists of two NAV modules, one in each MRC, one dual GS antenna, one marker beacon antenna with a duplexer, one dual VOR localizer antenna, one per NAV module. Press Radio button on the MCDU to go to radio page 1 of 2. On radio page 1 of 2, it is possible to tune and activate the ILS VOR frequency. The tuning can be accomplished using the tuning knob or the numeric buttons. If the tuning knob is used, the standby frequency must be boxed prior to pressing its respective line select key. If using the numeric keys, enter the standby frequency and press the respective line select key. To activate the standby frequency, press the respective active frequency. Press the respective standby frequency twice if not boxed, otherwise press once to go to NAV page 1 of 1.
On the NAV page 1 of 1, it is possible to capture a frequency tuned in memory. Press the respective line select key to box the memory tune and use the tuning knob to cycle the stored frequencies. Press the active frequency to capture the selected memory tune. Press the line select key next to FMS to cycle FMS Auto-Tune feature enable or disable. Press the line select key next to DME to cycle DME hold on or off.
The transponder system is an integrated part of the EPIC avionics suite. Transponder, XPDR. A Mode S transponder is installed in MRC1 and MRC2. Each transponder provides both conventional and enhanced ATC functions. Press the radio button on the MCDU to go to radio page 1 of 2. On radio page 1 of 2, it is possible to enter the transponder code. This can be accomplished using the tuning knob or the numeric buttons. The Automatic Direction Finder system is an integrated part of the EPIC avionics suite. The ADF module enables en route and terminal navigational and area guidance. The ADF has two selectable bandwidths: a narrowband mode to reduce noise during navigation use, and a wideband mode to improve clarity when listening to voice signals. The selectable modes are antenna, ADF, and beat frequency oscillator. ADF audio is transmitted from the digital audio bus to each audio panel in the system. Press the radio button on the MCDU to go to radio page 1 of 2. Press Next button on MCDU to go to radio page 2 of 2. On radio page 2 of 2 is possible to tune and activate the ADF frequency. The tuning can be accomplished using the tuning knob or the numeric buttons. Press the respective standby frequency line select key twice if not boxed. Otherwise, press once to go to ADF page 1 of 1. On the ADF page, it is possible to capture a frequency tuned in memory. Press the respective line select key to box the stored tune and use the tuning knob to cycle the stored frequencies. Press the active frequency to capture the selected stored tune. The Distance Measuring Equipment System, DME, is an integrated part of the EPIC avionics suite. The DME system enables en route and terminal navigation and area guidance. The DME is capable of tracking 4 channels to provide slant range, time to station, and station identification. Frequency tuning is automatically paired with VHF NAV. The DME can also operate in the hold-on mode, in which case the frequency is not paired with VHF NAV. When only one DME is installed, one station ident channel is for the captain's active frequency and the other for the co-pilot's active frequency. The DME system consists of DME module and a DME antenna. A second is optional. The DME interfaces with the display system and FMS through the ASCB D-bus.
Press the radio button on the MCDU to go to radio page 1 of 2. From there, press the 4th left select key twice. Press the line select key next to DME to cycle DME hold on/off.
The airplane is equipped with the WU-660 weather radar system model. The weather radar system is designed for detection and analysis of the weather during flight. The weather radar system consists of an integrated receiver transmitter antenna unit, RTA, and 2 virtual weather radar controllers. The RTA is mounted in the nose of the airplane, whereas the virtual controllers consist of the CCDs and the weather mode information displayed on the MFDs below the weather information. The antenna is normally stabilized in pitch and roll using attitude information from the IRU. The weather radar system is powered by 28-volt DC from SPDA-1 DC bus 1. If a power supply failure occurs, the weather radar system will be inoperative, as there is no backup power source for this system.
Display of weather data is available on the MFDs and PFDs. Selecting Weather Soft Key will display Weather Radar Virtual Controller on the MFD. Default operational mode is off, but selecting Weather following a cold start will activate the system after approximately 90 seconds. Weather Power-Up. Functions are displayed in the virtual controller in white, if available, when a specific weather radar mode is selected, and displayed in gray if not available for the selected weather radar mode. Only one of the operational modes, Weather, GMAP, Standby, and Off, can be selected at one time. Availability of other functions will depend on which of these four modes is selected, and if the airplane is in the air or on the ground. Selection of weather data display is accomplished via MFD using a soft key to select Map menu. Selecting weather from this menu will display the weather information overlay to the map display.
The weather mode is used to detect areas of severe weather. This will allow the pilots to avoid areas of dangerous weather conditions and possible turbulence. Selecting Weather activates the weather mode and deselects the previous mode. Ground Mapping Mode, GMAP. This mode is used to alert the flight crew about hazards caused by ground targets. This is especially useful in areas of rapidly changing terrain, such as hilly and mountainous areas. Therefore, the selection of preset gain will generally provide the desired mapping display. However, the pilot flying may desire to manually decrease the gain. It is possible to have the pilot working the GMAP mode while the other pilot is using the regular weather mode. Off mode. Selecting this mode turns the radar off, provided Off is selected on both virtual controllers. The system is no longer radiating power and the antenna is stowed. Slave mode. Slave indicates that one controller is in the off position while the other one is in control of both sweeps. Weather radar information on the PFD can be selected by pushing the Weather button on the display controller panel. The weather radar indication will then be displayed within the HSI format. Weather radar operating functions. The radar processes return signals in order to determine if a turbulence signature is present. Turbulence may only be engaged in the weather mode and at selected ranges of 50 nautical miles or less. Range. The range function is controlled via the outer knob on the CCD and can be set to 10, 25, 50, 100, 200, or 300 nautical mile ranges. The gain control varies the RTA receiver gain. There are two gain modes, variable and calibrated. The preset calibrated mode is the normal mode and is used for weather avoidance. The system will be forced into calibrated gain when RCT or TGT are selected. The variable gain mode is useful for additional weather analysis and for ground mapping. In weather mode, variable gain can increase receiver sensitivity over the calibrated level to show weak targets, or it can be reduced below the calibrated level to eliminate weak returns. Target Alert monitors for red or magenta weather beyond the selected range and 7.5 degrees on each side of the aircraft heading. If such weather is detected within the monitored heading outside the selected range, the Target Alert annunciation changes from a green armed condition to an amber alert condition on the MFD. This annunciation advises the flight crew that potentially hazardous weather lie directly in front and outside of the selected range. When this warning is received, the flight crew should select longer ranges to view the questionable target. The target alert is inactive within the selected range. Selecting target alert forces the system to preset gain and turns off variable gain mode. The normal radar sweep is plus or minus 60 degrees from the aircraft nose at a rate of 12 sweeps per minute. Selecting the SECT push button reduces the angle of sweep to plus or minus 30 degrees and increases the sweep rate to 24 sweeps per minute. The inner knob on the CCD provides tilt control and gives the pilot manual control of the antenna tilt angle. The CCD inner knob is a dedicated tilt knob if variable gain is not active. Tilt can be varied between 15 degrees up and 15 degrees down. Clockwise rotation tilts beam upward to plus 15 degrees, and counterclockwise rotation tilts beam downward to minus 15 degrees. The tilt control knob also provides the flight crew with the ability to place elevation control under altitude compensated tilt, ACT, which adjusts the antenna tilt in relation to the altitude and selected range. The tilt knob can be used for fixed offset corrections of up to 2 degrees. The react function permits the radar receiver to automatically adjust sensitivity to compensate for attenuation losses as the radar pulse passes through weather targets on its way to illuminate other targets. The react compensation is active in all modes except ground mapping mode. The cyan field indicates areas where further compensation is not possible. This is a warning indication that attenuation is hiding possibly severe weather and should be considered very dangerous. Test. The test function is selected on the Multifunction Control Display Unit, MCDU, avionics test page. The test is used to select a special test pattern to allow verification of system operation. Lightning Sensor System. The lightning sensor system detects and locates areas of lightning activity in a 200 nautical mile radius around the airplane. The system displays lightning rate of occurrence and position relative to the airplane. The Weather Radar Virtual Controller includes the LSS operating modes. LX mode activates the LX mode on and off. LX clear. Past strikes and symbols are cleared. When pushed, after 3 seconds the equipment enters the pilot-activated self-test mode. Lightning Sensor System Symbols. 1. Rate of occurrence symbols. Lightning rate symbols and their location represent the lightning rate of occurrence for the last 2 minutes. Rate 1 represents a single strike. Rate 2 represents 3 strikes. Rate 3 represents 6 or more lightning strikes. 2. alert symbol. Lightning activity that only provides bearing information is displayed as a magenta alert symbol for 5 seconds. The Flight Management System, FMS, manages navigation sensors to produce the airplane position. The system provides data for the cockpit displays and flight control system. The FMS serves as an aid to navigation, flight planning, and performance. In dual mode, each unit can provide data to the other unit. In case the FMS is unable to operate in dual mode for any reason, it will either operate in independent mode or in single mode. In independent mode, each MCDU controls the on-side FMS. And in single mode, both MCDUs will be connected to one FMS, one at a time. The FMS1 function resides in MAU2 in the forward electronics bay and receives power from DC bus 2. The FMS2 in a dual installation resides in MAU3 in the center electronics bay and receives power from the essential bus. The FMS is mainly composed of the following components: 2 multifunction control display units, MCDU, 1 data management unit, DMU, optional, MAU hardware, 2 processor modules with FMS software, 1 database module. The FMS interfaces with the following systems and equipment. GPS. The FMS uses inputs from the GPS to calculate aircraft position and perform navigation functions. IRS. The FMS uses inputs from the IRS to obtain aircraft position and perform navigation functions. VOR-DME. The FMS uses VOR-DME as the primary short-range navigation sensors to perform navigation functions, whereas INS and GPS are used as a secondary source. MFD and PFD. The FMS provides data for display navigation guidance on the PFD and navigation map data on the MFD. The Multifunction Control Display Unit, MCDU, located on the control pedestal, provides control functions management and operating modes for proper FMS operation. It is the interface between the FMS and the flight crew. Flight planning. In general, flight plans may be divided into 4 categories: active, stored, lateral, or vertical. Active flight plan. This is the flight plan currently being flown. The active flight plan can be entered waypoint by waypoint, loaded from an external source, or recalled from storage. At a minimum, active flight plans must contain a from waypoint, possibly the origin, a to waypoint, and a destination. A flight plan is considered closed when the last waypoint is the destination. Stored flight plan. The flight plan is said to be stored when it is saved in the computer's memory and can be recalled later and made the active flight plan. When entering a flight plan to store, the flight plan must have an origin and destination waypoint, and both must be database waypoints. When recalling a flight plan, entering the name of the flight plan results in the flight plan becoming active. If the name of the flight plan cannot be found, the flight crew can enter the origin and destination. If any are found, the flight plan list page is displayed to allow selection of a flight plan. Lateral flight plan. The lateral flight plan begins at the origin. The default origin in the active flight plan is the nearest airport to the present aircraft position that is within 3 miles, but it may be changed by the flight crew. The flight plan ends at the destination, which must be entered by the pilot as there is no default destination. The flight plan is built by inserting waypoints or strings of waypoints between the origin and destination. Examples of strings of waypoints are Standard Instrument Departure Procedures, SID, Airways, Standard Terminal Arrival Procedures, STARS, and Approach Transitions. Vertical Flight Plan. Vertical definitions for waypoints can be made using the line select keys on the right side of the flight plan pages. No vertical entries are required to operate the vertical navigation mode, VNAV. The FMS supplies predicted information for each waypoint, which is sufficient to define the vertical profile. The following information is displayed and/or entered for each waypoint in the flight plan, such as altitude, speed, angle, vertical speed, constraint type. Database. The FMS has 3 databases in its memory: a navigation database, a custom database, and an aircraft database. Navigation database. This database contains data on nav aids, airports, and airways. The information in the navigation database is updated every 28 days. The database contains 2 consecutive effectivity cycles, and the correct database may be automatically or manually selected. Automatic selection occurs upon entry of a valid date. Dates are valid if they are less than or equal to the expiration date of the current cycle. Custom database. The custom database contains information entered by the pilot. This is where the pilot can create and store flight plans and waypoints. This database is not updated on a scheduled basis. Aircraft database. The aircraft database contains all aircraft-specific performance parameters. After each flight, all learned data is saved to the file automatically. Therefore, all performance data, learned and fixed, is contained in the file. Performance. This function gives access to performance-related pages, including performance initialization, climb, cruise, descent, wind, fuel management, and takeoff and landing data. In addition, permits the initialization of stored flight plans and executes performance computations. Navigation. This function gives access to index, providing access to position sensor data, stored flight plans, fix info, selection of waypoints and maintenance pages. In addition, in this page, it is possible to perform data loading using a remote terminal or DMU. Flight plan. This function provides flight plan data for each leg in the planned, active flight plan, including course, distance, and FPA altitude constraints. It is also possible to create a flight plan, select a stored flight plan, and load a flight plan from a disk. Progress. This function summarizes important dynamic flight parameters and the airplane relationship with the active flight plan, such as estimated time en route, distance to go, fuel information, current nav mode, number of long-range navs used, nav aids that are presently tuned, FMS navigation mode, closest nav aids, and air data information, current speed, altitude, and temperature.
The FMS vertical navigation VNAV function calculates a vertical profile based on performance initialization data and defines the vertical modes for the FGCS. VNAV information can be accessed anytime via Progress 2, 3, and VNAV data. In addition, FMS VNAV data will also be displayed on the PFD and MFD. Note: VNAV can be previously armed by pressing VNAV button on guidance panel, and once aircraft is crossing 400 feet during climb, VNAV will be automatically armed. If VNAV is not armed and the aircraft is already above 400 feet, crew can also manually activate VNAV by pressing VNAV button.
The following general rules apply for VNAV operation. In order to use the VNAV function, the FMS performance initialization must be completed and confirmed. VNAV never exceeds the set altitude in the altitude selector. The airplane climbs whenever the FMS VNAV is in the climb phase and the altitude set in the altitude selector is above the present airplane altitude. The airplane descends whenever the FMS VNAV is in the descend phase and the altitude set in the altitude selector is below the present airplane altitude. A vertical track alert, VTA, is issued 60 seconds before the FMS commands a climb, descent, or 1,000 feet before the level off altitude. There is no VTA if leveling off is based on the altitude set in the altitude selector. VNAV defines constant climb or descent paths whenever existing constraints allow it. FMS controls and indicators, Multifunction Control Display Unit, MCDU. The MCDUs are installed on the central console located next to each crew member seat and are easily accessible and readable. The main controls to select alphanumeric inputs and the various FMS functions are: two sets of line select keys on each side of the MCDU, the alphanumeric buttons, the function buttons, the previous, next, and clear delete buttons, the tuning knob, the FMS button on the display controller selects FMS as the primary navigation source and toggles between FMS sources. The following FMS information can be displayed on the PFD. FMS source information. FMS lateral deviation. FMS vertical deviation. VNAV altitude constraint annunciation. Vertical track alert annunciation. The FMS button on the display controller selects FMS as the primary navigation source and toggles between FMS sources. Vertical profile on map or plan menus selects vertical profile flight path data for display. Progress on map or plan menus selects flight progress data for display. The following FMS information can be displayed on the MFD. FMS source information. FMS lateral deviation, FMS progress window, vertical track line, VNAV altitude constraint annunciation. The FMS has 4 databases in its memory, including the company root database. The company root database is a single file that can contain up to 2 data cycles. Each route contains the origin, destination, and en route waypoints.
Selection of a company route flight plan is performed via the Route RTE function page. It provides the flight crew with the means to enter a company route available from the NDB navigation database or uplinked through the data link.
Entering a valid company route name into the line 2R results in the NDB stored origin, destination, and en route procedure being entered into the route. A valid entry matches an uplinked route if the airline operational communications data link option is enabled, or it matches an identifier in the navigation database company route file.